Alright, so I want to look today at finding probabilities when, say, we want the probability of being in a range that's not exactly on a certain standard deviation. Okay? So maybe we don't want it exactly from the 1 standard deviation below the mean to 2 standard deviations above the mean or something like that. Let's say for example, we have this bell curve here, and let's say that our mean is, say, for example, 30, and then we have a standard deviation of 2, so let's say it's 32, 34, 36, and so on. We have 28, we have 26, and we have 24. Now, if I asked you for what the probability of being between 26 and 36 was, you could figure that out. Okay? The problem comes when we want the probability of our random variable x being between, let's say, 27 and 31. Okay? So, we've got this, and we've got this. Okay? And we would be looking for this. Okay? Now, remember, I told you that when we were finding probabilities, we're actually finding the area under a curve. Okay? I showed you this probability density function earlier. Okay? For this situation here, we have x being distributed normally with a mean of 30 and a variance of 4, or 2 squared. Okay? That's our notation we looked at on Friday. Okay? X is distributed normally with a given mean and variance. If I wanted to graph this, guess what? I could plug it into this, and I would have f of x equals 1 over 2 square root of 2 pi times e to the negative 1/2 times x minus 30 over 2, and you don't have to write this all down, this is squared. Okay, this is just a sample. Alright, if we punch this into our calculator, we would get this bell curve.
You mean like the entire bell curve or just that section?
No, you would get the entire bell curve because x is any real number. Okay? Now, the fact of the matter is, the highest this would actually go is, a very small fraction, so you'd have to zoom in a whole lot to see it. Okay? But you could do it. Okay. Now, the problem lies in this, all right? We don't know calculus yet. The area under a curve is found by doing some calculus. It's the integral. If we wanted this area, it would be the integral from 27 to 31 of, I'm not going to rewrite the whole function again, that function f of x with respect to x, okay? We don't know how to do integrals yet, so we can't do it. But thankfully, our calculator knows how, and our calculator even has a built-in function, so we don't even have to type in all of this stuff. Okay? And that's what we're going to look at today. All right? So, everybody get out your graphing calculators. This is the part I've been warning you about. You cannot do this without a graphing calculator. Okay? Alright, so if you do not have one in front of you, you need to get next to somebody who does. So actually, why don't you scoot up next to Winnie so that we only have 2 people sharing one, okay? Does anyone have the Nspire or no? Okay, good. We're just dealing with 2 different calculators here. Alright, so there's a function on your calculator called the normal CDF. What this stands for is the normal cumulative density function, okay? Cumulative meaning that it's going to find an area within a range, okay? Now, believe it or not, you've probably used functions on your calculators before that take certain arguments. For example, if you've ever typed in sine of 30, okay, and it spits out a half, sine is a built-in function. You have to plug in an angle and it gives you a value. Alright? This is a function as well, except it takes 4 different values. Okay? Now, the lower boundary is going to be the furthest point to the left that you want, the lowest number in your range. The upper boundary is the highest value in your range. Okay, so if we're trying to find, the area from here to here, okay, right here, this number is our lower boundary, and right here, this is our upper boundary. Okay, what? The mean will be given to you, and the standard deviation would be given to you.
That's nice.
Okay? So like in the example we were just looking at with the bell curve, we had a mean of 30, a standard deviation of 2. Okay? Now, you've got to be able to find this function. Alright? So for all of you, if you look, there's a VARS button. It's over kind of near the arrow keys. Okay?
I found it in catalog. It took a while.
Oh, yeah, you can find it in catalog. It takes a while to scroll down there and find it, but
Where? This?
VARS, if you look right above that, you see DISTR. That stands for distributions.
Is it normal CDF? Yes.
Okay? Now, listen, there are a lot of distributions. There's a chi-squared, there's the Bernoulli or binomial distribution that we've actually worked with. We just didn't call it that. There's the Poisson distribution. There's a lot of different distributions, okay? We're going to use the normal, and you'll notice there are 2 of them listed there. You've got to use the normal CDF. The normal PDF is for graphing. If you wanted to go to y equals and use the normal PDF, you could graph a bell curve, and you wouldn't have to type out the whole ugly function. All right? So, look at VARS right here, but you don't want VARS, you want what's above it, distributions. So hit second distribution, and it's number 2, normal CDF. Okay? Now, if you have a TI-83, you're going to see this, normal, whoop, you won't see that, it'll be spelled right, normal CDF, parenthesis, and it's waiting for you to type in everything.
Yeah.
If you got the 83, you're going to need to remember what order these go in. Okay? The 84 gives you a nice little menu that says lower bound, upper bound, mean, and standard deviation. Okay? If you have an 84 and it doesn't, you need to upgrade your firmware so it will. Okay? But you're going to type if in this example here, if we want what percent of the data lies between 3.5 and 6, if our mean is 5 and our standard deviation is 1, we're going to type in, 3.5, comma, the comma is right above the 7 key, 6, comma, 5, comma, 1. You hit enter. On the 84, at the bottom it says paste. Basically, it's constructing this for you. You hit paste and it's going to put it on your home screen there. And then you can hit enter and it will calculate it. Okay, comma is right above the 7.
Above 7.
Yes.
This is why I like Algebra 2 so much. It was all
Alright, so now, check this out. We've got what percent of the data lies above 3.8. Now, this is where it can be a little bit, you gotta be careful, okay? It's not tricky or anything. You just have to think and you've got to be careful. Alright? Listen, please. Hey, there's too much talking going on. So, we want the percent of the data that lies above 3.8. Okay? So if you look at our bell curve, just kind of going back a little bit. Alright, the mean was 5. Here's 4, here's 3. Okay? So here's 3.8, and we want this all the way up to where? Infinity, that's right, okay? Problem is we don't have an infinity button on our calculator, alright? So, when we do this, the question is, what do we put in for our upper bound? Because our lower bound is 3.8. What do we put in? Yeah, that'll work great, one. You just put in a really big number, okay? That should do it. Alright? And the reason is this. Remember we said on the right hand and on the left hand side we have an asymptote at 0. And it's getting smaller and smaller and smaller. And even once we get out here 3 standard deviations away, there's only a 0.15% left outside of that. So if we go to 9999, we're like 9,994 standard deviations above the mean. That ought to be sufficient if we're going to round to a couple of decimal places, right? I mean, we're talking about millionths of a percent at that point, if not smaller. So just pick a really big number and go there as your upper bound, and then you put in your mean and your standard deviation, just like we did. And what do we end up with?
0.8849. Oh yeah.
Okay, 0.8849. Alright, so if you're going to round that and put it as a percent, 88.5% approximately. Okay?
So what are the upper and lower bounds?
Yes.
But can we put put 5, like the mean, as our upper bound? Then we get the result, then we add 50%.
You know what? That's an excellent idea. If you wanted to do that, you could. Did you guys hear what Winnie just asked?
Yeah.
She said, could we just do normal CDF and do it 3.8 up to 5? That's excellent thinking right there, okay? Because that is going to actually give you a 0.385, right? But then you know everything above 5 is 50%. So you just need to add a 0.5 to it, and you get that as well. Alright? So, excellent thought there. You can definitely use that if you want. Okay? Alright, any other questions you guys have? Alright.